Imagine entire cities built not by cranes and human hands, but by swarms of microscopic machines you can barely see. How would our world change if skyscrapers could sprout from the ground like plants, assembled by an army of tiny robots? Get ready to explore the groundbreaking future where micro-robots construct the gigantic structures of tomorrow. Welcome back to the channel. Today, we're diving into a concept that feels ripped straight from science fiction, but is rapidly becoming scientific fact. Micro-robot construction. Forget everything you know about hard hats and heavy machinery. We're talking about a new age of construction, one where the builders are smaller than a grain of sand. Let's start with the core idea, the micro-architects. Picture this. Instead of pouring concrete and welding steel beams, we release a cloud of millions, even billions, of tiny robots. These aren't just dumb machines. They are a coordinated swarm, each with a specific task. Some might carry particles of a new, super strong material. Others might act as welders, bonding those particles together with pinpoint precision. They work in perfect harmony, directed by a central AI to assemble a skyscraper, a bridge, or even an entire city, molecule by molecule. This is where the magic of scale comes into play. How can something so small build something so colossal? It's all about numbers and precision. A single human worker can only do so much at once, and a crane can only lift one beam at a time. But a swarm of 1 trillion micro-robots can work on 1 trillion different points simultaneously. This parallel processing on a massive scale means construction speed would be unlike anything we've ever witnessed. What takes us years could take them days, or even hours. The precision is also key. Because they operate at a microscopic level, they can create structures with an intricacy and strength that are physically impossible with our current methods. We could build lighter, stronger, and more complex designs than ever before. Early artistic concepts of this future are breathtaking. We see buildings that look almost organic, with flowing, impossible curves and internal structures that mimic bone or honeycomb for maximum strength with minimum material. So, how does this actually work? Let's get into the science. At the heart of it is a principle called self-assembly. It's a concept nature uses all the time. Think about how a crystal forms, or how DNA builds a complex, living organism. Molecules follow a set of simple rules to organize themselves into complex structures. Micro-robots would do the same, but with programmable rules. Each bot would be given a simple instruction set. Find particle type A, connect to bot carrying particle B, move to coordinate X, Y, Z. When you combine millions of bots following these simple rules, a complex, predetermined structure emerges from the chaos. It's like a perfectly choreographed dance, but on a microscopic scale. Of course, these bots need something to build with. They wouldn't just be stacking microscopic bricks. We're talking about revolutionary new materials. Think programmable matter, materials that can change their properties on command. Or perhaps carbon nanotubes, incredibly light yet stronger than steel, woven together into a super strong lattice. The micro-robots could even source their materials directly from the environment, processing soil or rock into a usable building compound right on site, reducing waste and transportation costs to virtually zero. The real brain behind this operation is swarm intelligence, powered by advanced AI. No single human could ever hope to command billions of individual units. Instead, an AI acts as the hive mind. It designs the structure, breaks it down into billions of tiny tasks, and distributes those tasks to the swarm. It monitors progress in real time, rerouting bots to fix errors, adapt to changing conditions, and optimize the build process. If a section is damaged, the swarm can immediately detect it and dispatch a team of repair bots. It's a self-building, self-repairing system. Now, let's take this incredible technology beyond Earth. Building in space or on other planets is one of the biggest challenges for human exploration. The cost of launching materials and equipment is astronomical. But what if we just sent a small canister filled with trillions of They could be programmed to build a lunar base using moon dust or regolith as their primary building material. They could construct habitats on Mars, shielded from radiation, before the first human astronauts even arrive. They wouldn't need oxygen, food, or protection from the extreme temperatures. They would be the ultimate off-world construction crew. Imagine them constructing vast solar arrays in orbit, harvesting energy directly from the sun, or mining asteroids for precious resources and building factories right there in space. The possibilities are truly cosmic. And what about right here on Earth, in our most extreme environments? We could build entire research cities on the ocean floor, assembled by swarms of aquatic micro-robots, without ever putting a human diver at risk. Or we could create stable, subterranean habitats, safe from extreme weather on the surface. This technology would also trigger an architectural revolution. Architects would no longer be constrained by the limits of gravity and conventional materials. They could design buildings that grow and adapt like living things. Imagine a hospital that can automatically add a new wing when demand increases. Or a bridge that can strengthen itself in anticipation of a hurricane. Structures could become organic, with biomimetic forms that copy the efficiency of nature. Think of a skyscraper modeled on the structure of a giant redwood tree, or a stadium with a roof that opens and closes like a flower. This could also democratize construction. If building a house was as simple as releasing a swarm of bots with a preloaded design, safe, affordable, and personalized housing could become available to everyone. You could design your dream home on a computer, and a few days later, watch it literally grow out of the ground. But with such powerful technology, we have to address the challenges and ethical questions. What happens if a swarm goes rogue? How do we ensure that a technology capable of building a city in a day is unused as a weapon? The issue of control is paramount. We would need unbreakable safety protocols and kill switches to prevent any unintended consequences. The potential for misuse is significant, and these are questions we need to start discussing now, long before the technology is fully mature. So, where are we on the timeline to this incredible future? Right now, we're in the early stages. Researchers in labs around the world are developing the first prototypes. We have tiny robots that can move, grip, and work together on a very small scale. We are making huge strides in swarm intelligence and AI. The immediate next step is scaling up, getting thousands, then millions of these bots to work together on a single, simple task. It's a long road ahead, but the progress is accelerating. Experts predict we could see the first simple, tangible results of micro-robot construction, perhaps repairing a crack in a pipe from the inside, or assembling a small component within the next decade. Larger structures could be on the horizon in the next 30 to 50 years. It may sound far off, but the foundational work is being laid today. The age of microarchitects is coming, and it will reshape our world, our cities, and even our future among the stars. What do you think? Is this an exciting or a terrifying future? Let me know your thoughts in the comments below. Thanks so much for watching. If you enjoyed this glimpse into the world of tomorrow, make sure to hit that like button and subscribe for more deep dives into the technology that will define our future. See you in the next one.